And welcome everybody to the Daily Space Weather. Here's the sun at 131 angstroms from the Solar Dynamics Observatory. We saw two B-class flares in the upper range of the B-class flaring range, and the arrival of some high-speed coronal hole wind. Densities got pretty high yesterday as well, but otherwise, very low levels of solar activity. Also, there's a coronal mass ejection watch in effect. Let's take a look at the viewpoint from Stereo A, the Core 2 coronagraph. Stereo A coronagraph 2. Now, for you new viewers out there, congratulations on finding our channel, first of all. We only forecast coronal mass ejections in approximately this area. We don't do it in this area. We only do it in this area. Because from the perspective of Stereo A, Earth is off in this direction, and while we could forecast coronal mass ejections over here, we choose not to, as they are not affecting the Earth. Again, Lagrange point 5 is located out there. It's a gravitational equilibrium point where we can put a spacecraft and it will trail the Earth in its orbit around the Sun. So there we go, coronal mass ejection watch in effect. And now we've brought up a 4-day video here. So this is 171 angstroms ionized iron from the Solar Dynamics Observatory. And this is from Sunday through today. And basically you're seeing a degradation of sunspots there. And here's another SDO video. This one is the intensitygram, and you'll see these sunspots degrading and degrading. We're going to be back to 0 sunspots today, it looks like. So all current estimates indicating we'll be back to 0 sunspots today. I think we already are at 0 sunspots. And that's the solar intensitygram from Sunday through today, the 28th of July. So here's where planets and so on are located in the solar system. We'll advance this 1 week. There's 1 week from now on August 4th. Here's what's going on in the sky above my head. I use in-the-sky to make my star chart. This is the all sky chart, if you're wondering. Just put in your location. This yellow line here is the ecliptic, and if you're up before dawn, you may see Saturn and Jupiter and the moon up there near the ecliptic. Radio flux has dipped down to 80. So 80 solar flux units. Here's the 1-year chart to put that in perspective. The 10.7 centimeter radio flux, the proportional sunspot number data set. You can see how similar this graph is with the black line with respect to the red line. Red line sunspot number, black line radio flux. As solar cycle 25 progresses very slowly here. And NOAA was quite close with its forecast here for geomagnetic unrest. Only off by a few hours there for the geomagnetic unrest associated with the coronal hole high-speed wind stream. We'll get to it in a minute. First, earthquakes. Not many of them in the past 90 days. Indeed, only 1 in the 7 magnitude range. It's officially an earthquake drought, folks. So here's the USGS list. No major quakes over the past 24 hours. And if you're in an earthquake-prone zone, please have an earthquake plan, as earthquake droughts end in large earthquakes, historically. Why that would suddenly change, I don't expect it to, so know which building facades may collapse in the event of a major earthquake in your location, especially if you're in an earthquake-prone zone. Some quakes here in Iceland, actually, including a 4.3 and a 4.8. I think the largest of the past 24 was this 5.3 at Samoa. So pretty calm conditions when it comes to seismicity. Again, a 7 magnitude earthquake drought continues over the past 90 days. Only 1 7 magnitude quake, and we're almost at the 90-day mark here. We're pushing it as this earthquake drought continues. Next, volcanoes. Karimsky has been exploding, producing an 8,000-foot plume of volcanic ash over the Kamchatka Peninsula. That's eastern Russia, by the way, if you're not geographically skilled. Suwanosejima in the Ryukyu Islands. Flight level 100, it's producing a 10,000-foot plume of ash. Mount Ibu exploding. Flight level 080, 8,000-foot ash plume there. Cinnabung. An uptick there at Cinnabung. It's explosive activity being produced. And a flight level 230. It's a 23,000-foot plume of volcanic ash there. Luatolo now on the list once again. About a 7,000-foot ash plume there. Semeru on East Java, Indonesia, exploding. 14,000-foot ash plume above East Java from Semeru. And Great Sitkin, alert level remains at orange. The lava dome continues to accumulate in the inner summit crater with a current diameter of approximately 130 meters. Fuego exploding, producing a 15,000-foot ash plume over Guatemala. Nevado del Ruiz exploding, 20,000-foot ash plume over the Colombian volcano. Sangay and Revenador in Ecuador, both exploding. 22,000-foot ash plume from Sangay. 16,000-foot ash plume from Revenador. Sabancaya exploding. 24,000-foot ash plume there over Peru. Nevados de Chilean exploding. 16,000-foot ash plume over central Chile. Dag, that's a lot of earthquakes. Please don't pole vault the caldera. No matter how bad the economy gets, and no matter how utterly ineffective and ridiculous your government creates mandates and does all kinds of nonsensical things that are completely ineffective, I would remind you that asymptomatic people don't drive pandemics, sick people do. Which is why non-pharmaceutical interventions are entirely ineffective at stopping pandemics. So no matter how bad anything gets, please don't pole vault the caldera. This public service message brought to you at massive personal risk and expense by smAsho.com. Please visit our links and support the channel by becoming a patron or perhaps picking up some merch. Links available at smAsho.com, smAsho.org. Will redirect you. So here you can see some B-class flaring here. Nothing in the C range. Just some B-class flares here over the past 24 hours. And the likelihood of solar flares going down precipitously as we see all the sunspots evaporating. No proton strikes here, no coronal mass ejections currently forecasted to strike the Earth, just a coronal mass ejection watch in effect. And the GOES magnetometer looking very spiky here. The Earth could suddenly snap into a North Pole current sheet again. Let's take a look at that for some analysis of heliospheric current sheet polarity. So here is the top view ecliptic plane field plot. The data is pretty old here, over 4 hours old, nearly 5 hours old. And it looks to me like Earth is about to snap into a North Pole current sheet. You can see this North Pole current sheet shown here in green. This is South Pole. And that modest little current sheet is about to be in Earth's past. And barring some sudden change in the magnetic environment, I would expect Earth to be in a North Pole current sheet by tomorrow's daily space weather video. So make sure you check it out. And here's a line of sight ecliptic plane field plot. Basically the same data, showing you the three-dimensional version of the current sheet here from the perspective of Earth, also the solar magnetogram. And here's the coronal hole line of sight plot showing you the sun's B field in blue, South Pole oriented coronal holes in red, North Pole oriented coronal holes in green. And here's a solar flare monitor, and you can see dropping down to no sunspots detected there. Or about to. By the end of the day, it's going to be zero sunspots, folks. Just keep in mind the magnetic environment can suddenly change with no warning. So here's the Geomagnetic unrest, you can see, kicked off here right after midnight, somewhere in the 3-hour period following midnight. So NOAA was quite close with its forecast there for the arrival of the high-speed coronal hole wind. Solar wind density made it all the way up to nearly 50 protons per cubic centimeter here. That was close to the peak there. That was around, just around midnight there. 0 dark 24. So 24 minutes after midnight, the solar wind density was nearly 50 protons per cubic centimeter. Since then, as we forecasted yesterday, the solar wind density dropped down and the speed came up, a standard signature of a coronal hole wind stream. So current conditions are subsiding of the density there, 9.65 protons per cubic centimeter for the solar wind density. Solar wind speed just over 400 kilometers per second. Well off of its highs here. And it did reach up to about 450 kilometers a second there. So perhaps a short-lived coronal hole wind stream. I would expect this to continue on for a little longer. In any case, here's the pressure surrounding Earth. And the scale here is in nanopascals. That's magnetohydrodynamic pressure. And quite a bit of pressure here induced by that higher speed solar wind regime. Also, there is some negative BZ component associated with this. The BT-BZ have been shifting. So you can see this shifting of the BT-BZ ever since the density started to subside. The top pane here, that's the BT-BZ, the total field, and the extent to which the field is polar. So when you see a BZ of 0, that means that both poles are equally contributing to the total field. For instance, at this moment here, each pole is contributing like a very similar amount, about 5.5 nanotesla to the total field. Anyway, continuing on. A little bit of a reduction in pressure there as the solar wind speed has dropped a little bit. When we look at ground magnetic perturbations, we see quite a few, quite significant ground magnetic perturbations. So we're showing the polar view. We'll also show you the auroral forecast. So here's 4 hours of data, the polar view. Ground magnetic perturbations, changes to the Earth's B field. And please leave a comment if somebody has you scared and spooked about the polar excursion that's going on. And here is the flattened global view. And for you new viewers, Earth currently has 2 north poles. There's one over northern Canada. There's one over Siberia. And the South Pole is someplace down here south of Australia in the Southern Ocean, off of the Antarctic continent. It's a major polar excursion, folks. And here's the auroral forecast now that we've showed you the Earth's B field. Pretty calm conditions here for auroras. A little bit of an uptick there. Mostly in the southern hemisphere. Central Canada should have been seeing some auroras. Almost making it down to Minnesota there. So again, congratulations on realizing that our channel exists. We have a theory, and the theory is that the algorithms dislike us. So in any case, please tell your friends and foes about the channel, share it on your social media, let folks know that we're out there forecasting coronal mass ejections, something nobody else is doing, probably because they can't. I imagine they probably would if they could. We're also on BitChute. Check us out over there. We're on twitch.tv/smAsho as well. We regularly do live streams on Twitch. Today's cosmology segment's integrated into the daily space weather video. And this is a galactic merger. that we're looking at here. You've got this small satellite galaxy up here, which is believed to have passed through this other galaxy, which caused, shall we say, perturbations in the stars. So that's believed to have created this ring-like structure here, and there's actually, you can actually see a little bit of evidence of some filamentary connection between these galaxies here. That's the astronomy picture of the day at apod.nasa.gov. The ring galaxy, AM0644-741, located at about 300 million light years. So some pretty good imagery there of that. And I would also note that Cygnus X3 has actually done something that we've never seen it before do on the historic graph. So the brightest intrinsic object in the sky, Deneb, has an object known as Cygnus X3. So it's made up of a Wolf-Rayet star being orbited by a more massive object with one of its jets oriented directly at us here on Earth. And if you look at this slope here, this most recent downtick, it looks like none of the other downticks on the chart. This one here was a very sudden downtick, and this one has this slope to it. A different type of signal showing up there in Cygnus X3. And over the past 30 days, you can see it's been in a quite quiescent state here, right on the 0 line, which coincides with, historically speaking, way down there. So perhaps a new pattern emerging here from Cygnus X3. We highly encourage radio astronomers to go check this out with your radio telescopes. While it's in its quiescent state, we want to see it transition from a quiescent state to an X-ray loud state. And that's today's cosmology segment. It was brief, and again, integrated in the daily space weather video. Don't forget to check our playlists, as we've got over 200 cosmology segments at youtube.com/smashomash/playlists. Next, looking at the electron environment, we do see some minor charging hazards over places like central New Mexico and the central Pacific. Some minor charging hazards and some chaos in the electron belts. Here's a one-year chart of the relativistic electrons surrounding planet Earth. That's from solon.info, by the way. And here's a 3-day chart, and you can see this sudden drop-off. We often see that with coronal hole wind streams. And here's the NOAA forecast for the electron flux. This observation is going to be a little bit lower here, as we just saw the graph. I don't think that's updated yet. But you can expect to see a minor dip there in that. Here's a diagram of Earth Van Allen belts to give you a visualization of what you're looking at. And here's the total air column in terms of electron density. So we do see some chaos here. We're seeing some electrons lining up someplace besides around the equator. Most GPS errors occur around the equator at noontime. And especially during coronal hole wind streams, we see chaotic bands of electrons. So you're going to see some significant electron density dipping down here into the Indian Ocean. As we let this play through a second time here. So some unexpected GPS errors perhaps occurring there in the southern Indian Ocean. The entire Indian Ocean, really. Next, we'll look at the ionosphere. Here's a diagram of the atmosphere. Feel free to pause the video on this frame. It shows you thermosphere temperature, radiation penetration, and layers of the ionosphere. And we ain't got no ionosphere map. So unable to animate the map today. The data will not load. I'll demonstrate in the video. Previous day, 2 hours per second. That was sitting there trying to load the entire time while we were doing show prep. So I'll just press refresh once again here and show you the current ionogram. That's actually quite old here. So perhaps some missing data there from Australian Government Bureau of Meteorology. That's the latest ionogram that we see. By the way, we'll be doing a meteorology segment as well. Make sure you check that out. Today's will be a separate video. And here come our bonus features. So this is the ground-based observatory at Lurmouth, Australia, and it turns out the sun is going to explode and we're all going to die. So you can see the sun clearly exploding here. Sorry to break this bad news to you, but we're all going to die. It turns out all the alarmists on YouTube must have been correct. I think probably Nibiru is emerging from the North Pole of the sun right now, coming to seal all of our doom. Just kidding, folks. Those are clouds. Anyway, look at all the filaments. You see all these dark regions here on the sun? Those are all filaments. And that is why we have a coronal mass ejection watch. We can't tell you how we do the forecasting, as we got to write a paper about it before we release anything on the internet. There will be a coinciding video with that. Here's the SUVI map, the GOES 16 SUVI map. And you can see all those reddish-orange regions on the Earth-facing portion of the sun there. Those are all filaments. And we do expect some of those to be erupting. In fact, there's a prominence right down here that you can actually see looking like it's producing some activity here. That could be the coronal mass ejection actually starting as we make the video. Continuing on, here is the latest intensity gram. We press refresh so you can see it. And it looks like we've got 0 sunspots, folks. I don't see anything resembling an umbra. What about you? Here's the colorized magnetogram. We've pressed refresh on that as well. So there you go. We're getting this bowling ball look. Check it out. Here's our thumb hole. And here's your index and ring finger holes, or middle and ring finger holes. No sunspots. A downtick in solar activity. And we'll close out this edition of the Daily Space Weather at 94 angstroms. So it looks like the flaring is still coming out of these areas. You can see some brightening there in this ionized iron emission spectra, 94 angstroms from the Solar Dynamics Observatory. And this is just the past 24 hours of data approximately. We'll zoom in a little bit to show a little bit additional detail there. Again, thanks for tuning in to the Daily Space Weather. Congratulations on realizing our channel exists. Check our other videos in our playlists. We'll see you next time. May that solar wind be at your back.